Hello and welcome to another tutorial. So this time we're going to be making lightning, but in particular we're going to be looking at a way of making lightning procedurally. So we're going to make sure that it hits a very specific point, and we're going to construct it so that it sort of has the main sort of trunk to the lightning and then forks that can spread out. And then we'll set this up so then we see the visuals for it. So there's going to be a lot of maths and a lot of setting up of stuff till we actually have it there and running. That's one of the things with stuff like this. There ends up being a lot of setup and a lot of infrastructure. So we're going to put that together. It is going to be a thing where there are a lot of bits and pieces that we are having to build there first, though, before we get to see anything cool. But the payoff at the end of it is going to be we get some really cool looking lightning. So let's dive on in. Okay, so we need to start building up the lightning. So I've got a default scene here. I am using the high-def render pipeline just because, if you're going to make lightning, might as well do it in the high-def pipeline because that's going to look really cool. The process here, though, would absolutely be applicable for any of the pipelines, and while the particular visual asset that I use in terms of the material is one that is going to be specific to the high-def pipeline, all of the logic, the infrastructure, everything like that is going to work in all of the pipelines without any issue. So, okay, what I want to have is I want to have a lightning generator, and we're going to set up script. So in terms of scripts, we're going to have a couple of different ones. So we're going to have one for the lightning generator. It's going to manage and coordinate a bunch of things. So we'll link that script up. We'll also have a script for the actual lightning bolts themselves. So I'll have a lightning bolt script. And then the lightning bolts we build. So with this, there's a particular visual style I'm going for. So I want them to be, the lightning bolts to be made up of cubes. Now the data that we generate, you could use this to generate your lightning using, meshes, line renderers, things like that. In my case, I specifically want cubes for it because I think it gives a really good appearance, but you could use other ways of actually generating then the sort of geometry for the lightning if you wish. And I'll also set up a script for the element. So those cubes that make it up, the element is part of that. We could generate an entire mesh for it, so that is a thing that you could use approaches to generate a full mesh, but in this case I want to use cubes for it. So I'm also going to set up here, we won't make it empty, we'll make it that we have a cube. This is going to be the lightning target, and we'll make sure that's in view, which it is. So that's going to be where we fire the lightning at. So, okay, there's a bunch of things we're going to need to configure with this. Now, the way we want to approach this is because lightning plays out over time. So I'm generating it procedurally. So I want to start from a seed point at the very top. And then I want to project that, or essentially grow that down and have chances for it splitting off. So data-wise, I can actually organize this as separate slices of the lightning. But each slice isn't a slice in terms of distance, it's actually a slice in terms of time. So it will correspond to when those particular segments of the lightning are visible. That's going to be how we go about approaching this. So, okay, for this, I'm going to have a debug tool that is just going to be generate lightning. And I will also have a debug transform, and this will be the lightning target. So what I want to be able to do is in something like update, go, hey, that's set, well, firstly, we turn that off. And then I want to be able to go, cool, build lightning. And I want you to strike this particular location. So I want you to strike this position and might want to have it strike from a certain height. So that actually could be a common parameter that we have here. So lightning height, which we might say 75 meters. So I want to be able to do something like this. So I'm a big believer in, when you're setting up interfaces for things, building it based upon how you want to use it. Because that way then you don't end up building something that's different to what you need. So this is how I want to be able to work this. I want to be able to say, here is the point where I want the lightning to hit, and here is the height that that lightning is going to be generated from. So then I have build lightning, which I will actually make that public because other things might want to make use of this. So we're going to have our target and our height. So then we can start to think about, okay, so with the lightning, it's going to be procedural. And I want that trunk of the lightning to be able to move somewhat, which means it's not going to necessarily hit that target if I just, started at a very specific location. So what we're actually going to do is we're going to start at height above target. And then I am going to generate all of the lightning elements. And then I'm going to recenter them. So the last point there on the trunk is actually at the target point. So it means our source point for the lightning is going to vary, but that's okay because it's lightning. We're not doing electricity arcing between two locations. With that, we would need to do stuff where we're fixing those start and ends. In this case, we're doing something that we need it to hit a specific location, but where it gets to from there, as long as it's roughly the right height, that's the main thing. So, okay. Let's start getting the lightning sort of set up. So, okay, we're going to have our lightning bolt is a prefab. So I'm going to set up a prefab here. Game object, lightning bolt, prefab. And what I will do, so I'll go, okay, well, lightning will instantiate that prefab. Now, I'm not going to, I want to position it at that point so we can take a look and see our different instantiation options. So we can see, we're not going to give it a parent, but we do want to give it a position. So we'll give it a target. And we can just use the identity rotation. We could rotate it as well. That would absolutely be an option. So we have our lightning game object. Now this, we're going to know that it has the script on it. So lightning game object, we want to get component. We want to retrieve the lightning bolt script. So this is our lightning script. And then what I want to be able to do is tell it to actually build. So lightning script, build. So I want to give it that target point. Although it could actually go and check its location, so we probably could get away with not giving it that target. But we do need to give it the height, and it is going to need other settings as well. But for now, what we can do is we can create an empty object, lightning bolt. We attach our prefab or script to it. Going to set up a folder for prefabs and bring that in here, because then our lightning generator will be able to link that up. Now the build function we need to actually set up. So we're going to go to our lightning bolt. We'll have a public void build where we give it the height. So that looks pretty decent. So we can check and make sure that that's working. And we'll just link that up. Prefab linked up, we've got the target linked up. So if I, even at this stage, if I go and run this and tell it generate lightning, I should see it spawn one at the exact same location as the target, which it has, which is great. That's what we wanted. So, okay, it's spawning the lightning bolt, but we're going to configure the lightning because it's going to have settings and everything for it. So this is something where we've got scenario that had other things where we have a lot of different settings that need to actually pass through to this because the lightning has quite a few aspects to it that configure how it's going to appear. So what I often do in cases like of this is I will set up a object. So I'll set up something like lightning config and I mark as system serializable. And then in here, I would have a lightning config, and we pass this through. So that actually mean that height, we could have the height be part of that, but it'd be kind of nice to be able to control the height that things get spawned at. So we're going to pass through that config so that now it's very easy for us to pipe settings through. Otherwise, what you end up finding is you end up with lots and lots of parameters, which gets messy and it's also error prone. Okay, so config-wise, there are some key things we want to be able to control. So overall for the lightning, we want to be able to, so I'm spawning cubes, so I want to be able to have it that at the very top, these are quite large cubes, and then they shrink down. So that's something where I would like to have start cell size, which is going to be at the start of the lightning bolt. So I'm going to say that it starts at 0.5 meter. Then we want to have our end cell size. I'm going to say that's 0.2. So keep it fairly, that it goes to a fairly small size. Then I want to be able to control it branching. So we don't want it branching too much, and I don't want it always branching at the same rate. So we want to be able to vary this. So I want to have minimum or min branch interval, which I'm actually going to make reasonably high. And I'm going to have a max branch interval, which I'll make even higher again. So it'll pick randomly and that will determine when it chooses to have the lightning branch. So, okay, be able to have it branch. Well, branches, I'd like to be able to control the length of them. So I'm going to say, okay, similar thing, min branch length, which I want that to be a reasonable distance. I want that to go fairly large. And this is all in terms of these cells, which each cell, the size will vary. So we also then have a max branch length. And again, 50. And part of the reason for that is, okay, when branches are, right up towards the top, I want to have really, really long branches. And then as we get lower and lower and lower, I actually want to be able to reduce the size of those. So I won't do that initially. That is something that I want to be able to do. Now the branches, I want them to be able to choose a direction, and then they can choose to go vertical or horizontal as well. So I want to be able to control that because this is going to affect how kind of chaotic the lightning looks. So I want to have a branch vertical chance. So this is each time it expands that branch, a chance for it to decide to move up or down. So I'm going to keep that pretty low. But that is a ranged one. Similarly, when a branch starts, it picks a direction. So I want it to have a chance of retaining that, but also being able to deviate from that. So we're going to have a similar thing where we have a branch deviation chance. So this is how likely it is for that branch to, say it started heading north, for it to now head northeast. That's going to be the goal with that. So that I want to have reasonably high because I want the lightning looking fairly chaotic. So that's good. We've got stuff for choosing a branching, things like of that. So we can start to do some of the logic for building this now. So when we're actually going and building the lightning, there's a bunch of steps to it. As I said, we're going to start at a particular point, and then from that point, we need to expand out. So I'm going to refer to these as slices. So we're going to have a class here. I'm going to call a lightning slice. And these are slices in time. That's an important thing. These are slices in time. So they're not something that corresponds necessarily to location. It'll actually hold multiple cells, but it corresponds to a chunk of time. Because when we build this, I want to be able to have a stack of slices. And then we can set up our initial slice. So we can have our starting slice is a new lightning slice. And there'll no doubt be stuff we end up configuring in it. So we set up the first slice. And again, I'm writing this on the basis of how I want to be able to use it. So that starting slice, I want to actually be able to go, cool, well, let's add that one in. And then I want to make sure that I can configure it. So I want to be able to do something where I go, okay, well, starting slice, add cell. I need to know the location. So, okay, that's something I needed here is vector 3 start point. That's going to be, we can take vector 3 dot up by height. Because we're recentering everything and everything's being spawned under this prefab, we don't need to worry about the actual location. We've already been placed at the right location. So I want to add a cell at that start point. I want to know that this is a trunk cell. So I want to be able to go true. So a way of indicating this is a trunk cell. I need to give it its size. So it's going to start at start cell size. So that looks pretty good. So that means I need a lightning cell class. So lightning element is the spawned version of this. Lightning cell is essentially our planning and assembly version. So I know this is going to have a position. It's going to have is trunk. It's going to have a public float, cell size. And I know lightning slice is then going to have a list of lightning slices. So that looks good, which that can instantiate that. So that's our new list. So we know it also then has a public void add cell. And again, to avoid passing in lots and lots of things, I'm going to say that lightning cell has to be passed in. And we would just do slices add cell. So then here, well, I want to be able to go, it's a new lightning cell, and I want to be able to pass those parameters in, which I can. So in the parentheses, the braces here, what I can do is, and that should have been lightning cell. just fix this up so that it doesn't cause issues for us. So what I want to be able to do is in here, go, okay, well, position, that's equal to our start point. We then also have is trunk is true, and we also have cell size is equal to config start cell size. That's our start point. So this is just a really handy way if you're creating a class, makes it easy for being able to get everything populated in there. You don't need to set up parameters for it, which is really handy. So that's good. We have worked out our slice. We've added that in. So now the general approach is going to be, and this is one of the rare cases of where I use a while loop, I'm going to have bolt grew, which I will set to true. So while the bolt has grown, first thing I do is set it to false. So I grow the lightning bolt. So first thing I do is set it to false. Then what I want to do is I want to grab our current slice, and I want to grab the last one. Now, a thing that's been added in semi-recently in C# that is a really easy way of saying, hey, give me the last element. I can go _1. That'll give me the last element. And then I can say, cool, I want this. So the slice, I want it to be able to grow. Now it's going to need something like the config. So we'll also pass the config in with it. And I want this to then be able to give back potentially a new slice. So if there was a new slice, then bolt grew is true, and we go slices, add new slice. So did we add a new slice? So each slice as it grows, we tell it to expand, and it goes and then updates for us. Okay, so now grow is a function we need to add in. And that's actually where most of the logic lives. Lightning slice, row, and we provide the config. So most of the logic is going to exist here. So this is going to be lightning slice, new slice, will default to null. And so we can return that. So, okay. This is where we can start to look at how we go about growing this actual slice. So the bolt adds the initial slice, and then it drives the spawning of the slices within that. So to determine whether a slice grows, well, I need to traverse all of the cells. So for each lightning cell and cells. Now, whether this is a trunk or not is going to matter. So we will be checking if it's trunk cell, or otherwise then it must be a branch. So that is a thing we will be checking. And first thing though is we want to work out where the next cells, we're going to need to be positioning next cells. So that means the size has to change. So, okay, let's look at what happens with the trunk cell. So the trunk, we need to firstly work out, okay, what would the next position be? So that we'd have something where we have next cell position, and it's going to start at that cell position. And then, okay, well, let's forget any sort of size information first. With the trunk, it could move any direction that is one lower down. So it could be directly below, or it could be north, northeast, east, etc. We'll work with those compass directions. So it could be any of those. It can't stay at the same level. So it's definitely, we can add in a vector 3 down. So trunk is always lower. And then we would add, so we need to randomly be able to pick. So I want to be able to go a vector 3 forward multiplied by, I can do a random range, and I very specifically want to make sure I use integers here. I'm going to do -1 to 2. The reason I do 2 is it is exclusive with integers of the upper values. This means I could get back -1, 0, or 1. So that means it could either move it backward, stay the same, or move forward. If I then also chuck in on top of this a version using right, now we randomly pick a direction around us. So that's good. It moves lower, picks a direction. But this would not account for the cells changing in size over time. So that's something where I need to be able to calculate the cell size. But to do that, I need to have essentially a measure of how far through the lightning we are in terms of generation. So that's where, let me put that check in properly. That's where what I'm going to need to do is I'm going to need to work out the number of cells that we might have and pass that information through when it goes and creates the slices and sets that up. So the max trunk slices, now that is going to be height divided by n cell size, which is our smallest cell size. But we're going to then do a round to int, like that. Now, strictly speaking, we would actually not have that number because each cell is going to get smaller. It's not starting at that smaller size, and we could calculate the exact number, but we don't really need to. We get a good enough effect without doing that, so it's work that we don't need to do, so we can skip it. So we've got our max trunk slices. What that means is we can then work out our progress. So we could say here, float trunk progress is going to be slices count divided by max trunk slices, and we're going to turn that into a float. So we pass that in as well. So this is our float trunk progress, because what this will allow us to do then is calculate the size. Because I can work out, okay then, our cell size is going to be a mathflerp from our config and our min, or our start cell size, to our config end cell size based on trunk progress. So that's good. So now to calculate the offset. So the offset isn't just the cell size. So if I've got 2 cubes, if I just offset by the cell size, I'm not going to be at the right position. What I want to do is I want to take the size of the cell that we are using as our source, plus, I might rename that to next cell size. We add those two, and then we halve it. That's going to give us a valid offset. And then I can just do offset multiplied by that. So I've now got the position of the next cell. So calculate new position. Then what I would do is the new position out of range? In other words, has it gone below the ground? So I could check and see f next cell position dot y is less than 0, then there's actually nothing to do. I can just do a continue. We don't need to generate any further. Otherwise, well, if I need to set up a new slice, need a new slice. So f new slice is null, and new slice is equal to a new lightning slice like that. Then I can just add in that cell. So I can go, okay, well, new slice dot add cell. We say I'm creating a new lightning cell. Well, position, we've got that. Whether it's the trunk, well, we know it is. And then we also can say cell size is equal to the next cell size. So we add a new trunk cell. So that alone will give us the trunk appearing and being able to set that up. And so before we get to doing branching, I'm actually going to set up a couple of the other bits for this then. Because once we've generated all of the slices, we actually need to then go and perform our logic for doing the centering and everything like of that. So what I'm going to do is recenter the lightning bolt. So in order to do that, I need to find the last trunk point and a couple of other bits. But what I'm going to do is recenter lightning bolt, and I'll give it the slices. So that way I can have this, again, keep it contained as a separate function. So recenter the lightning bolt. We get a list of lightning slices. And I'm just going to traverse through these in reverse order. So index, it's like that. Then I want to grab that slice and I want to check through the cells in it. So for each cell, if that cell is a trunk cell, then the first one we find is actually our endpoint. So we know actual end. So find the actual endpoint. So then we can go, actual end is cell position. We break. We also need to know end found, so we can exit out of the other loop. So we've found the end there. We just check that here. So end is found, and we break. So we've got the location of the last trunk point of the lightning bolt. And that is the thing we need to shift back to 0. But what gives us the amount we need to shift everything by to get everything back aligned with 0. So move all of the cells. So a similar thing, slice in slices for each the cell in slice cells. And all we do is cell position minus equals the actual end value. That's going to bring everything back so it's properly centered at that end point. Then spawn the lightning bolt. So again, I'm going to pass through the config, and we'll have a function here, void spawn lightning bolt. Now our lightning config. So that reckons it's unassigned. We know that it actually can't be, but we'll give it an initial value anyway. So I'm going to bring this over, because what I want to be able to do is spawn all of the segments. So we're going to pass through slices to this as well. Bring this down. So the config doesn't have a prefab at the moment. So we're going to give it game object, lightning element, prefab. And what I'm going to then do is in the bolt, that's what it's going to instantiate. So our element game object, we instantiate config, that prefab. We are going to give it a parent and position. So its position is cell, position, identity rotation. Now we could do all of that. I could also just provide it with our transform, and then we go element game object, and it's transform local position. So we've now positioned it, so that's good. So the spawning should work. That kind of means if I set up that prefab and tell this to run, I probably should see something. Now we're not setting the size, so we might put that in as well. We have an element game object, transform local scale, it's vector 3.1 by cell size. So then over here, I'll set up the prefab, which the prefab is just going to be a cube. Cube, lightning element. Now we're not going to do anything fancy on it. Get rid of the collider though. Bring this over. And then I'll set that up here as a prefab. And we'll just put that into the config so that it's got access to it. And that should mean we run this and we tick the box, we should actually get something spawning. Let's run it. And then we'll tell it, generate lightning. And so we can see we have spawned, centered on it. Now, obviously at the moment, this doesn't look that much like lightning, and that's okay. Because there's changes we're going to be making, obviously, to this. We'll be setting up materials, things like that. But we've got it so that it's spawning the bits now. So that's good. So what we can now do is we can have it that the lightning can start to branch. And that's something where we do want to have a fair bit of control over when and how it branches, if we remember. So what we had is in our config, we did have settings here for that branch interval. So what I want to do is pick a branch interval. So int next branch, or branch countdown is a random range from config min branch interval to config max branch interval. And so every time we come in here, I'm going to go minus branch countdown. So update branching. If branch countdown becomes equal to 0, then I'm going to reset it. But I also want to indicate we should perform a branch. Cool. Perform branch. It's false. And perform branch gets set to true. So, okay, that would allow us to then here pass in a perform branch to the grow slice. So the slice just gets told, hey, you need to branch. So perform branch. So then trunk, after it's done this cell, is going to check and see if it should perform a branching. So this is where this is going to start to get messy if I keep adding in things here like this. So I'm going to actually set up a separate function, which will be void grow, and we'll call this grow trunk. We give it the lightning config, and we'll go from there. We'll work out what other ones we need to give it. So it clearly needs a lightning cell. It needs the offset and the next cell size. It needs to be able to, in that case, just do a return. Okay, it needs to be able to work with the slice. So what we can do is we can go ref lightning slice, new slice. And then here, I'm going to grow trunk. We provide the config, we provide the cell, offset, things like that, and the new slice. Now we want to check and make sure that that does correctly set up and be able to actually instantiate things properly. We're also going to chuck in perform branch. So I can have that here. And I'd be able to go, cool, well, if perform branch, then it'll be able to run some logic there. But I do just want to check and make sure that this is actually still working correctly. Because now that I know what it should look like, I want to make sure that nothing's breaking when I go and generate some lightning. You can see it's still generating, so that looks good. Excellent. So, okay, now we can make it do some branching. So if it's chosen to branch, we need to be able to pick some directions, things like that. So again, there's other little sort of helper things that we need to set up. So I want to have a branch direction, and this actually going to end up needing to make this public. I'm going to put it up here because I want that lightning cell to be able to access it. So we're going to have north, northeast, east. So we end up with a full set of ones. We'll also have a num values one. Because to make this a little bit easier, I want to have some helpers where I can pick a random direction, where I can turn a direction into a vector, and be able to pick also directions either side. So there's a few helper functions I'm going to set up here. So one of the things, I want to be able to get a random direction. So what it's going to do is do a return of e branch direction, and then a random range from 0 to e branch direction num values, which I have to cast to an int. So that gives me something that will pick a random direction. I want to be able to convert that to a vector. So I want to be able to go direction to vector. And that, well, this is something where we can use a switch for this. So we have as our input e branch direction. And what that is going to do, well, if it fails, it'll return vector 3, 0, but we have north. So we might decide north, well, that's going to return a vector 3 forward. And then we might say we have northeast. which that might be forward plus right. And then you can probably guess where I'm going with this. We then have south, which returns a negative of vector 3 forward. We have southeast, which is going to be a negative, also a vector 3 forward. We can start to bring in our other ones. So branch direction east, well, that would be vector 3 right. So we've got north, northeast, have south and southeast. We're going to bring in for southwest, which we subtract that one. And we're going to have west, which is just the negative. And then we're also going to have northwest, like that. So just give us a couple little helpers that'll make our life a lot easier for being able to perform the branching, because otherwise it gets a little messy. So with grow trunk, well, we want to pick a direction. So direction, we go get random direction. We can get the offset vector. So we might call it the direction vector. So we can go direction to vector. So we've picked stuff like that. Our next cell position, well, we can update the one we've already got. That is going to be cell position plus a direction vector by offset. So it makes it a bit easier for us being able to do the positioning of these. Then in terms of the rest of the logic for it, well, adding in the cell is easy. We add this in. Now that's not a trunk cell, so that goes to false. It would also be really handy to store that direction. So I'm going to put that into the lightning cell as well. So branch direction, just because that would be really handy so it can try and keep going in that same direction. So direction is equal to that. So we've passed in the direction. Well, branch, we want it to have a certain length as well. So I'm going to say that branch length is a random range from our config min branch length to the max. And how I can do that is I can have branch life remaining. And what we do is each time we continue on that branch, it will just actually decrease that life. So branch life remaining is equal to that branch length. That's good. It's performing a branch, it's adding that in. Well, that's for growing the trunk. We would then here have a grow branch that's going to need almost identical stuff, except we won't allow a branch to branch again. So what we will have, and I'll set this up here, grow branch. And it's going to have almost the same setup of things, except it will not have perform branch. Now, initial appearance for these is not going to be what we need, but that's okay. So what I would say is, well, if the cell life remaining is 1, we do nothing. So actually, 0 would make more sense. So essentially, if it's run out of life. So the final cell will still have a life of 0, but we just shouldn't spawn anything further. So, okay, if that's the case, well, we're definitely creating a new slice, potentially, if we don't already have one. So we're going to set that up. We need to work out our direction. And this is where we have that setup where we wanted to be able to randomly choose whether it's going to make a vertical deviation or whether it's going to make a horizontal deviation. So we're going to get those parts incorporated. Okay, so we've got neutron. We need to work out where the cell in this branch is going. And we did set up, as we sorted our parameters here in terms of the deviation there. So that's something we can use as a bit of a guide there of what we want to check is, should we firstly be changing direction? So, okay, well, cool, change direction. That's going to be, we can do a random range from 0 to 1, and we can check if that is less than our branch deviation chance. That's going to determine whether we should change direction. We could do a similar thing for if it should be going vertical or not, but we can actually just work our direction, that side, in a little bit easier. We'll see how we can approach that. So our new direction, well, if we are changing direction, then I want to be able to go get random adjacent direction to cell direction. Otherwise, I use cell direction. So that's how I want to be able to work with this. I want to be able to get a random adjacent one, which we can actually do that pretty easily. And this is why I set things up as sort of little helper functions. So I want to be able to go, okay, we'll get random adjacent direction. Now, we don't need to do this as something where we're doing a whole bunch of checks, things like of that. What we can do is we can do, okay, well, new direction. We convert direction to an integer. Then we add random range, and it can be -1 to 2. So we're using integers, so that could mean that it goes either side, or it could pick the same. Then we want to, because this could go out of range, things like that. So the way we make it work is we go, hey, new direction. It's going to be new direction plus the integer version of the number of values modulus with that same thing. This is why I set up that num values one, because this makes it really easy, apart from me generating random things, to be able to do integer math like of this. So this will guarantee I will always have a valid direction that comes back. Then I just return eBranch direction of new direction. So really handy way of being able to do that. So now we've got the new direction here. So, okay, well, that means our direction vector, we can go direction to vector of that. So determine the direction. So I've handled the horizontal side of things. The vertical side is actually pretty straightforward then. And we can use similar to what we have done before, where, okay, well, for the vertical side, we can go f r random dot range 0 to 1, that is less than config, and our branch vertical chance, then our direction vector dot y is a random range from -1 to 2. So we handle the vertical deviation. So far, so good. So now we've got a new direction vector, which means we can work out our cell position. Because our cell position, next cell position, is going to be cell.position plus our direction vector by offset. So we've got the new position. And that means we can also just take this, we're adding in the new cell, and we can use it directly. So we paste that in. We have our new direction here. Our branch length becomes cell branch life remaining -1. So this should give us branches. Now, there's going to be improvements needed to this branching. There will absolutely be improvements needed to it. And best way to identify that is we run it and we'll see what it ends up looking like. So I tell it to generate. So in C, we generated it, and we got a few different ones, which is good. We did manage to get some ones that really looped around. So that could be something where we might want to potentially look at having stuff to avoid that. Vertical chance actually looks like it could go higher. I reckon we can go maybe 0.25. And if I get rid of that lightning bolt and generate another one, get a bit more in the way of verticality. So we probably do want to have actually quite a bit of a higher vertical chance and potentially lower the deviation chance. And so we'll generate the lightning. So that looks all right. That looks a little bit more chaotic, but, and this is one of the things that we do want to avoid, you see we get a branch way down the bottom here, which is not what we want to have. And generally with lightning, the branches decrease in size the lower we get. So that's something where I want to actually be able to control that. I actually want to scale the branches with the further down the trunk we get. So I'm going to set up an animation curve, branch scale with trunk progress. And the branches, because this is going to affect the length of them, I want to then have a branch cull length. So if a branch is less than a certain amount, it gets culled. So what I would be able to do, where I work out the branch length here. So I want to be able to go, okay, well, config, branch scale with trunk progress, evaluate that, add our progress, which we need to pass that through. We do have it up here, but we don't have it later on. So I'm going to pass that in. So we'll have a float trunk progress. We evaluate at trunk progress. And I want to say, okay, well, branch length, if I do a multiply equals by, that's not going to work because we're mixing integers and floats. So what I have to do is a mathf round to int of branch length multiplied by that. So here we're determining the branch length. And what I would say is if that branch length is less than config cull length, then we just do a return. So really handy way of being able to work with that, because now I can configure that and this will prevent me getting branches that are really low towards the ground. So this is scaled with trunk progress, so the closer to the ground we get, the lower or the higher the trunk progress value is. So if I did this, it would make it really short branches up the top and really large branches down the bottom, which is the opposite of what we want. So I'm going to invert this and edit key to 0, but we could also choose sort of a cutoff height. We could actually bring this in earlier and maybe at 0.8. it already goes to 0. And our right tangent is linear. So we could do that. That's going to mean that it shrinks those branches as we get closer to the ground, which will be good. So now we generate our lightning, and we can see still getting some larger ones towards the ground. So we might find that we need to adjust those settings a little bit further. It might need to be more like a 0.75. And that will just give us a bit more of a sense. We could also just have a hard cutoff as well. So as well as just scaling the size there, we could have a public float min height to branch, and it just doesn't do any branches if it is below that height. So we'd be able to do another check here of f next cell position dot y is less than our min height to branch. We also return. So it's just going to give us a couple of controls that will modify the length of those branches and also prevent them from spawning really close to the ground, which we want to avoid because it just doesn't look great if they spawn super close to the ground. So that's better. We get some branches up high. So that's good. So now we're pretty close to being able to have it looking the way we need. There's a couple of things that I want to be able to do. One is I want the cubes to overlap a little bit more. So I'm going to have cell overlap. And we might make it 0.1. And then what this will do is when we were calculating those offsets, I'm just going to shrink that sort of size a little bit so that they overlap a chunk. So that was when we were working out our size here. So rather than being that, it'll be 0.5 minus config cell overlap. So that will reduce it. So that should be good. And okay, so we've got some overlap that will be happening. We can get the actual visual appearance a little bit better now. So what I would do is I would create a material. And this is going to be create material matte lightning element. So it doesn't need to be lit. I would actually make it unlit. I would also make it that what it's emitting is bright white. And I'd actually go for a pretty hefty emission intensity. So that then I can just as a test throw this in. And we'll put the material on it. And make sure that it's got that updated in the prefab. So then with that, our sky and fog volume, let's also make sure we've got, it's going to look best if we put in some level of bloom. So as soon as we've got some level of bloom happening, that's going to make that stand out a lot more. We do also currently have it that it's in daytime, so that's going to make it not stand out quite as much. But we can ramp up that intensity. We could go all out and go for really high values, but let's just keep it at sort of 30 odd is pretty decent. We could change things like rendering pass, which you might need to depending on your particular sort of settings. But that gives us our lightning element looks good. So let's test now how that looks. Should be looking a little bit more like what we're after. So that's looking nice and bright, which is good. And that overlap would allow us to, you can see there's a little bit of overlap happening. The more we adjusted that, the more overlap we would actually get there. So now we're ready to make the lightning actually do a flash. We've got all of those bits built, so we can now make it that it flashes. So I'm going to have lightning flash time, which should be pretty short. Like it should take a fairly small amount of time for it to actually appear. So I'm going to go with something, start with 0.5. We'll probably need to reduce that. And then each cell we want to persist for a chunk of time. So I'm going to have lightning persistence time, which I'm going to set to say 0.2. And then how this gets used is in the lightning bolt when we actually go and add each cell, we're going to then, so when we instantiate it, we're going to need to set those times. So, okay, we already have logic where we're doing the spawning. So that means we can work out our index in terms of our start time. So our start time is 0, and our time per slice is config lightning flash time divided by our slices dot count. And then every time we process a slice, we update the start time. But then each cell that we create here, we go, cool, well, get component for the lightning element. And we're going to need to store that. So we're going to have the element script. And I want to set its timing information. So I want to be able to go element script, set times, start time, and also give it its end time. So I want to then also be able to go start time plus config and its persistence time. And I'm going to also keep track of a list of lightning elements. So this will be our elements. And each one we retrieve here, I'm going to add into that. So spawn and configure every element. So spawn the game object, configure the element. So the lightning element, we're going to go and set it up so it's got those start and end times in it. So we'll have those configured. So it needs a public void set times, start time, and an end time. And the way we'll work it is the lightning elements will largely look after themselves, but we'll actually be driving them a little bit externally. So I'm going to have start time and the end, and we just transfer those over. Then what I want to be able to do is go sync to time, where we tell it the current time, and if that current time is less than start, or it's greater than or equal to our end time, then I want to actually turn off the mesh. So I'm going to set this up so it links to the mesh renderer. So what it will do is it will just go linked mesh, turn that off. Otherwise, linked mesh is enabled. But it would be really handy to know potentially if this is actually finished running. So that's something we could also be checking as well. So what I would like to do is a return current time is greater than or equal to end time. Essentially, is it done? So, okay, we've set the times, we've got our elements. We're going to cache the elements in our generator, sorry, in the bolt. So we set that up here. And then in our update, well, we want to basically start performing the lightning bolt. So we're going to keep track of our elapsed time. And so we'll do elapsed time plus equals a time delta. We loop through every element. So element in elements. And we go, hey element, sync to time. And then we want to say the elapsed time. We also want to keep track of if all done. So all finished. So we're going to assume that that is true. And we go all finished and equals, because as soon as any one of them is not finished, it will then say that it's not done. And then we go if all finished, destroy game object. So clean up once done. Update all elements. So it doesn't need to do much. We could do fancier effects, but because it fires that quickly, we'll find that we don't actually need to. So you can put that here. That'll automatically destroy itself when it's done. I will, in the prefabs, turn off the mesh by default. But now I should be able to tell it to generate lightning, and I should see a flash of it that hits that cube. And so we did get a null reference there. So that's one where we didn't link up the mesh. Very easy to have happen. So we need to go back to our element and link up the mesh. So I was trying to do it, but couldn't. So let's run that again. We tell it to generate lightning. So we get a flash. Now that, way too long. So we're going to drop that flash time to 0.25 and the persistence time to maybe 0.1. And let's try it again. Tell it to generate. That's better. That's sort of flashing. So it is still, there is that a bit of an appearance time. So we did notice with the lightning that it was seeming to really persist a long time. And that's because really easy to make mistake. I should have had an else here in the sync to time. It was going to be always turning the mesh to be on. Because if I run this now, and then we'll generate our lightning, we actually get it appearing and we see that fade in and fade out and that actual transition through the sky, which is exactly what we want. So we've got a lightning generator that can plonk a bolt of lightning at a location that we need, and that we can configure how it looks appearance-wise. Now I'm generating cubes for this, but we could easily adjust that, so you might be generating mesh or feeding the info into a shader. But we've got the data there that we can then be doing further things with if we need to. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, it really helps out, it's really appreciated. If you're looking for the code for the project, that code is available up on GitHub and the link to that's in the description below. I've also placed a link in the description to the video archive, which is a searchable archive of all of the tutorial videos that I've been uploading, so you can search based upon keyword, things like that. If you've got any questions, chuck in a comment below. And if you're looking for other ways to support the channel, I do have a Patreon, and there is a link to that in the description below as well. But until next time, bye.